Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 40, and this problem asks us to draw the product for each of the following reactions. So in A, what we have is this derived benzene being reacted with KMnO4, which what we know is it's a strong oxidizing agent. But what we know about KMnO4 is that it must have a hydrogen on the benzylic carbon in order to oxidize this carbon. So for example, this carbon, it has 3 hydrogens, so this carbon has no issues to be fully oxidized to carboxylic acid. However, this carbon, if I were to draw it in a stick, we see that this carbon has no hydrogens attached to it. So this KMnO4 is unable to touch this tertiary carbon, so it's only going to touch this carbon here. So we will only be able to oxidize fully the methyl carbon into our carboxylic acid, while because there's no hydrogens available on this central carbon here, nothing is going to happen to this bottom carbon. In B, we're doing some sort of bromination, but it's radical induced bromination using light as the radical initiator. And what we know about this radical mechanism is that the radical form at the benzylic carbon, which is the carbon directly adjacent to your benzene ring. So you're going to have bromination at this carbon position here. For C, we're adding this derived benzene group with our reducing agent. So we know this is a reducing agent. So just like in past examples, we know that it's going to reduce this ketone to straight chain carbon. So we'll get our alkyl product that looks something like this. So we have 1, 2, 3, 4 carbons. So 1, 2, 3, 4 carbons here. And now in this example, what we have here is we have this directing group, this alkyl directing group with diatomic bromine and the Lewis acid, and we know that this alkyl group is going to direct ortho and para. So what we're going to have is we're going to have two isomers, one being the ortho substituted isomer, one being the para substituted isomer. So one is going to be the ortho, and one is going to be the para substituted isomer. Now in E, once again, we have this carbonyl group here that's being reacted with some sort of reducing agent, this hydrazine and hydroxide anion. And once again, just like when you have zinc, mercury, and acid, hydrazine and alcohol reduces your carbonyl group. So once again, just like in C, we're going to reduce that group to a straight chain alkane that looks something like this. And last but not least, we have nucleophilic aromatic substitution, in which we have a strong nucleophile being this amine, and a good leaving group, which is a halide chlorine with a bunch of electron withdrawing groups, and this benzene, really making this benzene electron poor and electrophilic, therefore susceptible to nucleophilic attack and substitution to kick off this chlorine group here to give us our substituted product that looks like this.